Hello, welcome to Science Chomp. Today we're going to be looking at Atwood Machines Part 2. Now this situation involves an Atwood machine where you got mass on a table and one mass hanging off the end. Again, this string is meant to be massless, pulley frictionless. Now, just like previously, you want to work out the acceleration and the tension in the string. So let's first of all work out our forces, and then I'll redraw this thing. So again, here you've got, I'm going to call this M2, so M1 and M2, so the mass 2 times G. Now in this case, let's simplify G to be 10, really it's 9.8, so 6 times 10, which is 60 newtons. And here, what's interesting is we've got M1G. Now M1G is going to be 2 kg times 10, which is 20 newtons. But you've got a normal force up here, which is the same. It's also M1G, which is also going to be 20 newtons. Because this thing's not accelerating up or down, these things cancel each other out. So let's just put a line through these. We don't need to take those into account. Now, in this situation, it's a frictionless table. And I'll show you how to work out friction one in part 3. But for now, let's just figure this out. Now, this is dead easy, much simpler than the first one. So if we combine these blocks together, it's going to be like this. You got your 2 kg plus 6 kg. Okay, that's 8 kg. You got no force on that side and one force on the other side. So you got a force of 60 newtons over here. That makes it super easy. So it's 8 kg and 60 newtons, which means it's a straight acceleration is force divided by mass. So A equals F net over M, which is going to be force is 60 divided by 8. 60 divided by 8, let's get our trusty calculator out, which is 7.5 meters per second squared. Now for the second part of this, you want to work out the tension in the string. Now that's basically the same as what we've done before, and what you've got to do is you've got to zero in on one of these two masses. Let me do this 6 kg one. If you do it for that one, it'll be exactly the same. So let's just draw this thing. So you've got 6 kg. And on one side, you got M2G, which is 60 newtons. And on the other side, so opposite that, you got tension in the string. And we don't know what that is, but we know that it's accelerating in this direction at 7.5 meters per second squared. Okay. So in order to work out tension, again, we just need this. So F net is equal to mass times acceleration. Mass, in this case, is 6 times 7.5. Now for F net, because it's accelerating in that direction, the 60 newtons is bigger than t. So 60 minus t is 6 times 7.5. So let's work that out. 6 times 7.5, which is 45. So 60 minus t is 45. You rearrange it so that minus t becomes a plus and that plus 45 becomes a minus. So 60 minus 45 is equal to t, like so. And let's just finalize this. So 60 minus 45 is 15, so T is 15 newtons. Okay, so the acceleration is like that, and then the tension is like that. Thank you very much for watching. Goodbye.